In this video, we are going to solve reverse nodes in K group problem from the Leetcode. In this problem, we will be given head pointer to the linked list and we have to select K nodes and we have to reverse the order. After selecting the nodes in a group of K and reversing them, if we don't have K nodes at the end of the linked list, we just have to leave the nodes as it is. Consider this first example. Here they have given 5 nodes and K is 2 here. So we have to select groups of size 2 and we have to reverse them. The first group is this 1 and 2. When we reverse it, we are going to get 2 and 1. And similarly, the second group will be 3 and 4. When we reverse it, we are going to get 4 and 3. And at the end, we only have one node. So we are going to leave as it is. Consider this second example. Here they have given 5 nodes and K is 3 here. So we have to select group of size 3. When we select this first group, we have nodes 1, 2 and 3. When we reverse them, we get 3, 2 and 1. And at the end, we have only 2 nodes. We don't have a group of size 3, so we are going to leave them as it is. Let's go through some example to understand how can we implement this solution. Consider this linked list where we have 7 nodes 1, 2, 3, 4, 5, 6 and 7. And here the first thing that I'm going to do is I'm going to add a dummy head. For this example, let's consider K as 3. So we have to select group of size 3. This will be the first group. This will be the second group. Since it is a dummy head 0 that we have added, what I'm going to do is I'm going to keep a pointer that is group previous. So this represents whenever a group is present which is of size K, this pointer represents previous pointer to the group. And similarly, I'm going to get a pointer. I'm going to call this as group next, because this pointer represents the pointer which is next to the group. And this will be the kth node for the first iteration of the loop. So what I'm going to do is, once I get to know these pointers, I'm going to reverse the links. So 0 will be here, 1, 2 and 3. I'm going to reverse these links and I'm just going to write the output after first iteration, what is going to happen. The same process will continue for other nodes as well. So once we reverse these links, we have to connect here and then this node will be connected to here. So this is the only thing that we have to understand in order to solve this problem. So we are going to do some pointer manipulations. We will keep this diagram for our reference while implementing the solution. Let's implement the same solution that we have discussed. The first thing that I'm going to need is I need a pointer. I'm going to call this as dummy head. This will have a value of 0. Value is irrelevant, and it will be connected to the linked list given to us. And one more pointer that I need is group previous. So this is the pointer which is going to point to the previous node of the group that we are currently considering. So initially it will be pointing to dummy head. And then what I'm going to do is I'm going to write a while one loop, infinite loop, which is going to break out if we don't have K nodes which are going to be reversed. Then I need kth node. So what I'm going to pass here is I'm going to implement this function as well. Get kth node. I'm going to pass this group previous and value K. If kth node is not present, then I'm going to break out of this infinite loop, because we are done with reversing everything. If there is a group of size k, then we have to reverse I less than k I plus plus. Before reversing, let's store some pointers so that these things will be useful for us. The thing we need is group next. This is the pointer which is going to store the next node to the group. So we are going to refer our diagram once again. So I'm considering this group next as a next node to the kth node. And now we have to reverse these links. While reversing, one thing that we have to notice here is this first node have to be connected to this fourth node, because this will be the, once we reverse it, one will come next to the fourth node. So that's why we will use the typical reversing logic, but instead of initializing previous to null, what we are going to do is previous will be pointing to this particular node, that is group next. And then I'm going to declare another pointer named current. Current will be pointing to group previous next. And now we can start reversing these things. We need a temporary pointer to store the next node, because we will be modifying this thing. Current next, and then we are going to modify this current next will be pointing to previous, and we are going to treat previous as current, and then current will be pointing to next node. So now we have done reversing this part. We have reversed all the links. We have also connected this node to this node. Only thing pending here is the group previous should be connected to next node. So I'm going to declare another pointer named temporary, and I'm going to group previous. I'm going to store this pointer, because we will be modifying this group previous dot next, because group previous dot next should point to kth node. And then what I'm going to do is I'm going to assign this group previous. Once again, group previous will be temp node, because here once we rewrite this linked list, what is going to happen is here it will be 0 and 3, 2, 1 and 4, 5, 6, 7. So for the next iteration, group previous should be here. So that's why we stored previous, the pointer to this node, as a temporary variable, and now we are reassigning to group previous. And finally, after doing all these things, we are going to return dummy head not next. One thing pending here is we have to implement this function which is getting kth node of the linked list. So get kth node, we are going to get two arguments. First one is the node, and then we are going to integer k. So if that node is empty or k is less than 0, then we will return null. otherwise we are going to go for k iterations. While current node is not null and k is not 0, we are going to go through that linked list. Then we are going to decrement k, and finally we are going to return current. Let's run this solution and check whether it passes the initial test cases. Yes, as you can see here, this is passing the initial test cases. Let's submit this solution and check whether it passes all the test cases or not. Yes, this solution is passing all the test cases. If you are interested in learning more about other data structures and algorithm related problems, you can check out other videos from my channel. Thanks for watching this video.